So what is the stereochemistry of the product of this following reaction? And a 2 in front of the H, like so, that would mean a deuterium. Usually they put, a bond going to a D, that capital D. But in this case, they went ahead and labeled it isotopically, meaning it's a hydrogen with a mass of 2, which is where the name deuterium comes from. Duo 2, right? Okay, so this is just a heavy isotope of hydrogen. They have that to help you label where this group went. Okay, so what will be the stereochemistry of your product of this following reaction? So we have to figure out the 2 stereochemistries. What do we have here? Well, we have one spot right there, right? That's pretty obvious from the reactant, isn't it? And then we have a second spot that's going to end up being created because we're appending this with this group right here. You see that we're breaking that bond, and then we're adding this group to it. Notice this is a good leaving group right here. Okay? Okay. So this carbon right here is this. This hydrogen is that one. That makes sense? Fantastic. Okay. Right here on this carbon that's labeled number 2, by the way, they have the numbering done for you. So that's kind of convenient, right? Okay. So the carbon 2, does it show all the bonds? It shows how many bonds? 3, right? How many bonds does a carbon typically have? 4. So it's not showing a normal hydrogen, is it? Okay. And now we have a methyl group around it, right? We have the triple bond group around it. And then we have a heavy isotope of hydrogen and then a regular isotope of hydrogen, don't we? That's how many different groups? 4. And so that means that is a what carbon? Chiral carbon, right? Okay. Also, it tells you that. All your options are 2 as some sort of chiral carbon, aren't they? Yeah. Anyways, I wanted to point that out, that you can isotopically label, change one of the hydrogens to an isotope, and that would make that have chirality. Okay? Okay, so what we're going to have to do here is we have to, whenever we assign RNS, we always have to put what group in the back? A hydrogen, you got it. And so those 2 carbons here, they can be in the plane, can't they? And then this hydrogen right here, this would be, well, coming out towards me probably. And then the other hydrogen is probably facing away from me, right? Okay. And so what would then be the priorities? Let me check this out. Okay, so that's going to have that added on there. And that has to come on to the... Okay, so... All right, let's step back. I have a funny feeling a lot of you are still a little bit confused about what's going on with the product. Okay, so how you figure out the geometry of this product here is you actually have to look at this, okay? So if you think about the geometry of this group right here, right? Which is that carbon, right? Okay. This is really kind of an SN2 reaction, isn't it? Remember the SN2s? You're going to be making a carbocation, and that's going to attack this, isn't it? What did that do to the geometry of everything? It always flips it, doesn't it? Yeah. So because it has to come in the opposite side of the BR, doesn't it? And so it comes in the opposite sides of the BR, and that causes all of these to flip to the other side, doesn't it? Okay, does that make sense? Okay, fantastic. So there's actually an easier way to figure out the geometry of this, and that's to actually use this and then flip it. Okay? That's how I would normally do this, because it doesn't specify geometries over here, does it? So you have to derive the geometries for this from this anyways, right? Is that making sense so far? Okay, so if you do that, this heavier hydrogen is facing towards the back on this one, right? Okay. And that means the other hydrogen that we're not seeing here is facing what direction? Towards the front, right? It's facing towards me. Typically, when you assign R and S, you would do that with the lightest, the lowest priority one being towards the back, right? If you don't want to go ahead and, do the work, you can just assign it with it in front, can't you? And then you just get the opposite of whatever you get. Remember that? Any two groups flipped gives you the opposite. We used that trick a bunch of times back a few chapters ago. Okay. So our priorities on this is going to be, our largest priority is the BR, right? Okay. Our second priority is this one right here. And then our last priority would be that one, right? Okay. That is what? R, right? Okay. Because it's going right hand? Okay. Now, what happens to it? Well, first off, we're doing it for the wrong direction, aren't we? So that would flip it, R to S. And then we have a flipping of the entire thing because we're attacking it from the other side, and that's putting that long chain on there, right? So now we go from S to R. And we're back at R, aren't we? Can you understand what I just did? No? Kind of, maybe? Okay. What I did is I used the trick. I assigned something that's drawn out that I can do, right? I flipped two groups on it, and that flipped its geometry. So we went from R to S. And then I said, well, this is going to have this group attack from the opposite side of the BR. That's going to be your new highest priority, isn't it? So your highest priority is flipping sides now. We're again exchanging sides, aren't we? And what does that mean? Well, my geometry flips again, doesn't it? Yeah. So S back to R. Okay? Okay, that's one way you can do this. The other ways you could do this is you could continuously try to draw it out, which is going to be a lot more work and difficult, okay? The other way you could do this is going ahead and assembling this, reflecting things, and then assigning the geometry here, okay? So, in this case, we have the two hydrogen, the deuterium, facing away from us, right? This is going to react from the opposite side of the BR, isn't it? Okay. And so that would come in right here, wouldn't it? Is everybody okay with that so far? Okay. That would give you these in the plane, and your hydrogen would be going away from you, right? Your two hydrogen, okay? Your normal hydrogen, the one hydrogen, be coming towards you, right? Okay. Well, that's actually opposite again, isn't it? Yeah. So we assign the geometry again for this one where the hydrogen comes towards us and the two hydrogen goes away from us, right? We exchange the two, and that will give us our geometry. So we go ahead and do that. The highest priority is what again? This right here, right? Next highest priority is that, the methyl. The next highest priority is, And so that would give us S, wouldn't it? But we're doing it opposite, aren't we? We exchange the hydrogens, the heavy for the light, and we get R. Does that make sense to everybody? Okay. So you see that we can get it either way. Those would be my preferred methods to do it. The final methods to do it would involve making models for this or drawing these out. And then each time you do something, you figure out how that flips things. Okay? Which would take a very, very long time. All right. But again, you can use the trick and make your life easy, okay? I would highly recommend using the tricks. All right. Then we do this one, don't we? Okay, fantastic. So we need to go ahead and figure out its geometry right here, and that geometry should maintain, shouldn't it? Okay, so we go ahead and look at the geometry. What are the priorities for these groups? You guys figure it out. I don't want to. I've gotten enough practice on this. Thank you. So what's your highest priority? Or here, this is an easier one. What's your lowest priority? Do you have an H? You don't, do you? Weird, huh? Yeah, so what would be the lowest priority on this one? The methyl, right? Yeah, that CH3 will be your lowest priority for this one. And hey, that's convenient. That one's already in the back, isn't it? Hey. Finally, no extra work. What would be your next highest priority? So these are all CCCs. This one only has H's connected, so is your lowest, right? This one has one carbon connected, so it'd be your next highest, right? This one has 3 connected, because the triple bond, that counts as 3, doesn't it? And so that one's your next highest priority. Okay. What about F? Would that be higher or lower priority than carbon? Heavier or lighter? Heavier, right? So typically it is higher priority, right? Okay, and so that is, notice by the way, you can actually kind of do this in a number of ways. There's, you can figure out your lower priority ones or your higher priority ones. They all sort of work out the same way because, you know, if you organize them from left to right or right from left, it's still organized, isn't it? Okay. So what would that be then? Highest, second, third? Yes, you got it. You don't have to do anything to it, do you? No, because conveniently, the lowest priority was already in the back. All right. You okay there?
Yeah, she hasn't taken a test.
Oh, okay.
Hour just pulling this light.
Oh, wow. Yeah, that went on for a while.
Oh, it did.
Is everybody okay with that? Understand it okay? Fantastic. Let me know if you have any issues. Really, we're just